All right, so thanks everybody, and welcome to our talk on the three constants in life, death, taxes, and GUIs. I'm Anderson. I'll be covering the taxes portion of the talk.
And I'm Hank, and I'll be covering the GUI portion of the talk.
And unfortunately, our death guy couldn't make it, but we'll try to make up for that. So as kind of mentioned, I'm Anderson. I'm going to be talking about the taxes throughout this talk. I work on TaxBrain 2.0, which is one of the models we're going to be talking about today, and also tax data, which is just another project in the tax modeling ecosystem.
And I'm Hank, and I'm the core maintainer of Comp, which is going to be the GUI project that we're going to be talking about today, and Pram Tools, which is a project that's used by Comp.
So before we get into some of the details of this project, we wanted to provide a little bit of context around what's going on in the open source policy analysis community. So the Open Source Policy Center, where Hank and I both work, was established in 2013 with the sort of intention that if you apply some of the best practices that we apply to open source software, to open source computational models for policy analysis, you'll end up with better models, which will lead to a better policy analysis, which will ultimately lead to better policy and more informed policy debate. And Matt Jensen, the director of the center, actually gave a talk on this at AnacondaCon in 2017, if you want to go check that out afterwards. But since its inception, OSPC has been incubating a wide range of open source policy models covering topics from taxes to measuring the effects of the opioid crisis across the country. And in that same time frame, a lot of other groups like the Congressional Budget Office and the Federal Reserve have been releasing their own code and data around their models for researchers and economists to take a look at as well. And the newest player to the open source game has been the Policy Simulation Library, or PSL, which was established this past year, and is now home to a number of open source models for policy analysis. And each one of those models meets a couple standards for transparency to be included in the library. So with that, let's get into the actual projects. So first up, there's TaxBrain 2.0. This is what I've been working on for the past few months now. And what TaxBrain 2.0 is essentially an integrator for multiple tax models. So we're going to take a few economic tax models and put them all into one easy-to-use interface. So the original scope of the project was more to be a way to interact or to bridge the gap between these tax models and some sort of web application that would make the models available to a wider array of users. And while we were doing that, we decided to also make it usable as a simple Python package if you'd prefer to do that, versus working on some kind of web interface. So currently, TaxBrain only includes tax calculator and behavioral response models, but we're planning on adding a couple more in the future as some more are developed and we can find ways to integrate them into our work. So tax calculator is the first model that we added in. It's an individual income and payroll tax microsimulation model, which is really just a fancy way of saying it's TurboTax on steroids. So rather than trying to calculate tax liability for one individual as they input their information, we have a nice data set of about 250,000 representative tax units, and tax calculator will go through, read all the information on their income sources, any deductions, how many kids they have, et cetera, and calculate their tax liability both under individual income taxes as well as payroll taxes. And in the past, it's been used by presidential campaigns, journalists, policy analysts, students, and a number of other groups to analyze and debate tax policy. And it was also actually the back end of TaxBrain 1.0, which served as a web interface for this tax calculator model. And Hank will talk a little bit more about that project during his portion of the talk. Next up, we have behavioral response. This is the second package we put into TaxBrain. So this is a Python package for partial equilibrium behavioral response analysis to changes in the federal payroll and individual income tax code. So this is essentially saying that we know that people will sometimes change how they behave in response to changes in tax law. For example, if your marginal tax rate, which is that tax rate you're going to pay on the next dollar you earn, goes down, you might react by working a little bit less, because now you can work less but keep your after-tax income the same and keep the same standard of living. Or you might work a little bit more because now you'll be taking home more money. So behavioral response will do those sort of computations based on some user preferences for either of those reactions. But at this point, you might notice a couple of problems that you have with using these two models if you were to use them separately. First and foremost, you need to know each of them very well, not only the economics behind them, but how the project's maintainers decided to write them up for how you can integrate them into your code, or the way to interact with them just at all. And then there's also no way for non-technical users to really take advantage of these. So if you're just a Hill staffer and your boss has some idea for a new tax plan, but you don't have any idea of how to program, you can't use these models, and they're kind of useless to you. So I'll be talking about TaxBrain 2.0 and how that solves problem 1, and then when I turn it over to Hank and Comp, he'll talk about how we solved problem 2. So this is a sample of some code that you would need to write to do some kind of tax policy analysis without TaxBrain. So you need to import all of these different models. You need to create all these different Python objects. You got to specify your reforms and your economic assumptions and any behavioral assumptions. And you got to do this twice so that you have a model that's going to run the baseline policy as well as your reform policy. And then you have to actually loop through every year of your analysis. You got to collect all of your data, and then you got to crunch it all into one table. And you can get something like this, which is really just a data frame that shows tax liability over a 10-year budget window. So if you know those models really well, this is tedious but not necessarily impossible. But as you can kind of tell, there are a lot of ways that something could go wrong. You could just code something up wrong, pass something in somewhere it's not supposed to be, and it'll ruin your analysis. You'll have to start all over. But with TaxBrain, we've been able to reduce that down from 40 lines of code to about 7. So now you can just pass in what policy reform you want to test, what economic assumptions you have if you have any, and then what behavioral assumptions you have if you have any. Tell TaxBrain to run. It'll parse through those inputs, figure out which models need to be run, and take care of it all for you. And then you can produce this nice same table with significantly less work. So now that you've seen what it looks like just with the code, as I mentioned earlier, the point of this was to put it online and make it accessible to everyone. So let's do a quick live demo of TaxBrain on Comp. And so you can see what that looks like before Hank gets into his presentation. So this is what Comp looks like and what TaxBrain looks like on Comp. So as you can see over on this left-hand side, you have variables for the start year, what data you want to use, and you have all of these policy parameters. Let me zoom out a little bit. Right, so you have all these policy parameters like itemized deductions, personal income information, even universal basic income if you would like to model that. So let's just kind of make up a policy real quick, and you can see what it looks like when you're actually implementing your own reform, and see what's going to happen when we actually run it. So, and I'm not endorsing this policy in any way. I'm sort of making stuff up as we go, just so y'all get a feel for what it looks like online. So let's, for example, change the payroll tax rate that's going to be withheld from your income to 14.3%. We can scroll down through the deductions and child care credits, and we can take a personal exemption, and let's give everybody a $500 personal exemption. And we continue scrolling. You can see all these different tax credits we have, and we have it broken down into what kind of filer you are. And you can even hover over here to get a little more information about this policy. You can change if it's inflated by CPI or not. So we can keep going down. You'll see more that we have, even down to state and local taxes and some of those individual itemized deductions that you're going to have. But once you've done that, we can scroll back up once our policy is all created. And down here, and all we need to do now is click Run. And right now, this run is going to cost 1 penny. Hank will talk a little bit more about how sort of the compute costs are paid for. But we're going to hit Run Simulation, and it's going to give us this nice little slide. And while that's running, I'll turn it over to Hank to talk more about Comp.
Great. So Comp, it's an open source utility for running and sharing computational models. Technically, it's a Django application, and then the models are run on separate servers and celery processes, and there's a little Flask API server that the web app communicates to those workers on. And Comp empowers analysts who need to use and share results from these models, but they aren't able or willing to use the programming APIs. even people who are more technical and can use programming APIs and are happy to do so may enjoy using comp because you get these human readable names to the parameters. You can quickly see their default values. You can hover over the information widget and see some more information about each parameter. And then once you run that simulation, you can share it with technical and non-technical people alike, or you can share it with the public at large. Comp also allows you to provide access to models that are too resource insensitive to run locally or that use sensitive data. For example, TaxBrain uses a data set provided by the IRS. So you have to pay a bunch of money to get. And then once you get that data set, you have to run it through a bunch of data preparation scripts to get it ready to go with TaxBrain. But with comp, you can do some analyses on aggregated results from that data set without exposing any of the individual tax records. So how does all this work? Modelers can share their models for free, and users pay for compute, or the compute can be sponsored by a benefactor. So if a model is not sponsored, then the user pays for the computational resources that are used during that simulation. So that 1 penny price is the cost of the server per hour, and then you scale that down to seconds, and then you multiply that very small cost by the number of seconds it's going to take to run the simulation. And then that's accumulated over the month, and you're billed at the end of the month, and it's and right now the models online are very cheap. But or a benefactor can sponsor compute for these models, and then they would be charged for those computational resources, and then the users are able to use them for free. So why do we make comp? So we had this awesome web app in TaxBrain 1.0. It was actually developed by some Anaconda contractors several years ago. One of them was TJ Allenbo, and he did an excellent job. He did some work on some of the underlying models too. And eventually that project was passed to me around 1.5 years ago or so, and I've actually learned a lot about web development just from reading TJ's code. And so I have a lot of respect for these Anaconda contractors, so anyways, back to this web app. It was awesome, and we thought that every model should have its own web app. However, there's some problems. So with TaxBrain 1.0, there's no standard publishing process. So if you came to us and you said, I have a model and I want to put it on your web app and I want it to be just like TaxBrain, and say, oh, well, we have all this custom code that just works with TaxBrain, maybe we could repurpose that, but we're not really sure, which leads us to the next problem. We had all this custom inputs and outputs technology that was geared just towards processing data that's going to get passed to a tax calculator and for processing these tax calculator outputs. And that didn't really translate too well to other models. And the next problem was too much of the modeling process was in the web developer's hands. So over time, all the validation that the web app did and all the processing it did kind of became out of sync with tax calculator. And so some bugs started to arise, and it was the same thing with the outputs. There were these custom data structures that the web app had to work with and then serve to the users, and then the outputs for tax calculator changed, and sort of bugs arose there over time too. And finally, we had this dependency hell problem where we had a Django application, we had TaxBrain, and then we had another model all sharing the same environment. And so tax calculator would upgrade to the newest version of Pandas, and the other model might not have upgraded yet. And if it was a backwards compatible breaking change, then the other model would have to rush to upgrade to the newest version of Pandas, and then tax calculator the newest version of that couldn't be deployed as soon as we'd like, and it was just a really big mess, and no one had fun with that process. So when we made comp, we solved those problems. We standardized the inputs and the outputs, so we came up with a sort of a standardized inputs data structure that is rich enough to work with most models, and comp can use that to build the GUI page that Anderson showed you earlier, and then comp can process those inputs and get them back to that input format and give it back to the underlying models. And then the outputs, we decided that there should be basically two types of outputs. There should be outputs that are renderable, which are like tables or charts, and those can just be embedded in the outputs page, and they're outputs that are downloadable, and so those are like CSV files or something that you would download and look at on your own computer. And then we narrowed down comp's interactions with these models to 3 Python functions. There's one function to get the default inputs for the model, and then that's what's used to display the page. There's another function to parse and validate the user inputs, and so the user goes and they change some default values. Those are passed to the model via this function, and then there's another function that runs the model with those user inputs. And then finally, we solved this dependency hell problem by allowing each model to have its own custom environment that's decoupled from the web app. And so each model gets to build its own Docker image, and then that image is spun up into a container that's run in a Celi worker process, and then comp interacts with those Celi workers over a RESTful API via this Flask app that was in the middle of those. So what just happened when Anderson went to TaxBrain and changed some values and submitted a simulation? So first, page loads, and comp gets default values from TaxBrain. And so those are loaded up in this views module and shown to the user. The user makes some modifications to those parameters. Those go through some preliminary checks by comp to make sure there's nothing malicious there, and then they're passed to TaxBrain. And TaxBrain does some more model-specific validation and parses those parameters into the format that it wants them to be in. And then those parsed parameters and errors, if there are any, are passed back to comp. If there are errors, then they're displayed to the user, and the simulation is not run. If there are no errors, then comp calls run model. TaxBrain runs a simulation, creates some tables, and graphs, CSVs, and all of that stuff, and it's passed back to comp and shown to the user. So now that we know a little bit more about how comp works, I'm going to pass it back to Anderson to talk about the outputs page. Here we go.
Okay, thanks, Hank. So zoom out here. Okay, so this still is a little bit large, but I think it's good as we're going to get. So now that TaxBrain's finished running, this is what a standard output page is going to look like. And as Hank sort of mentioned, comp can modify this as needed to handle different types of model outputs. But for tax policy, obviously, the big thing we want to know is how much is this going to change tax liability over what's the 10-year budget window. So we have this first table. It's going to show changes in payroll tax liability, individual income tax liability, and total liability. Or you can also just look at your reform total tax liabilities under your reform policy or under current law. And of course, this table, you can download this table as well. You can come down here and actually view some of the inputs and policy changes you made. So this sort of dictionary structure is what's getting passed from comp to TaxBrain and then processed in the tax model. So it's going to have all of your policy parameters here. It's going to have some of that meta parameters like what start year, what data source you're going to use, all up here. And if you wanted, you could even just take this, save it as a JSON file and pass it straight into TaxBrain in the Python API, and it'll work just fine. But if you continue scrolling, you can get a little more detailed view of some of the effects of the whatever revenue or tax policy you tested out. So we can have this broken down into income bins, so you can see, how many people earning between $10,000 and $20,000 a year are going to see a tax increase or decrease. What percent is falling under each bin. If you want, you could view it as an income decile instead, so you can see 10 to 20%, 50% and up, top 1%, sort of whatever details that you need. And of course, you can view this table for every year in your analysis. If we wanted to come down and see what will happen in, I think that was 2028, we can do that as well. So it really just provides a very sort of flexible structure to look at your policy reform. And if you're in DC on the Hill or just sort of curious about how tax policy, what kind of effects it's going to have, this is pretty much all the information you're going to need for a nice high-level analysis. And it's now going to be all available to people who wouldn't have it previously because these models were held in a proprietary nature and is sort of generally unavailable. But of course, comp can host non-policy related models and models for other types of policy. So now I'll give it back to Hank to explain how you can publish your own model on comp if you're so inclined.
Cool, thanks. All right, so let's go over to the publish page. So if you want to publish a model on comp, then you would go over and get a really crazy rendering of that page. There we go, that's better. All right, so you would go in and you would fill in the name of your app. There'd be, you fill in a one-line description, a little, longer description of what your app is doing. For each of there's a section for like your model parameters, your Python functions that I was talking about, and you fill in all that data. You fill in the commands you need to install your project. How long is it going to take to run your app on average? What types of computational resources is your model going to need? And then if you have any other combinations that your app is going to need to run on comp, then you can reach out to me, and I'm happy to work with you on those. Then you go down, you click publish, and then I'm notified, and I check out your form. I start to plug in the data that you've given me, and then within 24 hours, I'll either have something that's ready to be published on comp, or I'll get back to you with some things that need to be fixed or updated so that your app can meet the comp criteria and it can be published. And I'm happy to work with that through that process if needed. And so with that in mind, we can move to the roadmap. And for the comp roadmap, you can see that the first item is that we want to automate this publish process. It's very labor intensive. You have to go in, you fill in this form. You have to read all the documentation. Then I have to go in and I have to read your form and start plugging in stuff with your model. And it's just a lot of human time is put into it. And so we want to try to get that as close to push button and publish as possible. Next, we want to try to have richer model inputs and outputs pages. We think that we can do a lot better job of allowing models to expose like more functionality through their inputs page by allowing more types of inputs and more flexible inputs pages in general. We want to have better outputs pages. We want to show more types of outputs like interactive charts or videos or photos or whatever it is. We want our infrastructure to be more scalable. Right now, everything's in Docker containers, but I'm kind of the container orchestrator, and so we want to try to automate some more of that process. We want to add a REST API, and finally, we want your model. So if you have a model that you want to put on comp, then I'm happy to work with you to get it ready to be published. Let me pass it back to Anderson for the TaxBrain 2.0 roadmap.
Yeah, so for TaxBrain, obviously, like any sort of young project, it's going to go through a decent amount of sort of refactoring to try to improve performance wherever we can. Some of the models that we want to put up on support with TaxBrain take a very, very large amount of time to run, and we really want to avoid adding to that with just unnecessary, inefficient code in TaxBrain itself. A project that I'm actually very interested in working on over the next couple months and would love some help from y'all if you might be interested in it is automating tax analysis reports. So if you pay any attention at all to tax policy, you've probably seen some reports from, say, the Joint Committee on Taxation, where they give you all these nice tables, giving you headline numbers on tax reform, a few charts here and there showing things over time, just sort of general information on what kind of effects a certain tax policy is going to have. So what I would really like to see done with TaxBrain is automating that whole process. So now instead of having to go in, run your reform, pull all your data, make all your tables and your charts yourself, you can just go, run your form, and then TaxBrain will produce some kind of report for you without you really needing to do anything. And obviously it won't be super sophisticated, but a nice basic headline number report. So if that's something that y'all would be interested in working on, please come find me after. I'll be happy to talk to you about it. And of course, we want to add more models to it. So right now we've only got 2, but there are a lot more out there and more being developed that we'd like to add support for in TaxBrain. So like the first one we want to add is OGUSA. So OGUSA is an overlapping generations model for fully dynamic analysis of tax policy changes. So this is going to start accounting for the macroeconomic effects in tax policy changes. How does it affect GDP growth, average wage growth, things like that. And then next up, we have Business-Taxation. So this is a U.S. corporate and pass-through business tax model. So this is going to measure the effects of, say, changing the corporate tax rate. or changing how depreciation can be deducted from your taxes, and sort of things like that, which are a really vital role in tax policy in general. Now, if my example from earlier where we only used 2 models didn't really convince you of a need to wrap these all into one thing, you might have thought it was pretty simple, and having a whole other package to do this is a bit overkill. You're not really wrong. Only using 2 models is relatively easy, especially when you know what you're doing. But let's look at the kind of relationships that you can have when you have multiple models. And some of these relationships are already happening now, and some could be developed down the line. We'll sort of see how these models develop. But you start with tax calculator and behavior response. And tax calculator is going to pass in some information to behavior response. Behavior response is then going to do some more its calculations, feed some information to tax calculator if you want, use a lot of tax calculator's functionalities, and there's going to be a nice little feedback loop there. But tax calculator can also pass information to business taxation, because if you're, say, self-employed, some of that information is going to be fall under both individual income taxes as well as your business tax liabilities. So there's going to be another feedback loop there. So continuing on, business taxation and OGUSA can, of course, have some relationship because, again, OGUSA, you're measuring macroeconomic effects. Business taxes are going to have some kind of macroeconomic effect. So you need to worry about that relationship as well. And then, of course, you need to worry about the macroeconomic effects going in between OGUSA and individual income taxes, because something like your average wage growth is going to change how much we're going to project tax liabilities to grow over time. So even though there's only a couple models right now, you can see how there's a lot of different relationships between all these economic models that will need to be accounted for in some way. And it'd be great to have just one nice, simple interface to run these models versus needing to run or getting to know all 4 intimately to actually use them. But of course, on the roadmap and sort of the next big sort of milestone, in my opinion, for tax policy will naturally be the 2020 election. And I'm sure that y'all have already heard plenty of news about the election. You might already be sick of it at this point. But as we get more and more people running, they're all going to be throwing out tax proposals. And we're going to need some way for reporters and students and people like you and I to sort of see what those proposals would mean for us and the economy as a whole. So during the past elections and during the debate over the Tax Cuts and Jobs Act, Tax Calculator played a very prominent role in opening up that process to every individual. And I would like to see TaxBrain develop into something that can augment that by providing access to even more models to journalists, students, the people trying to form these policies, and just you and I, so we can test these policies out for ourselves. So if any of these projects sort of interested you and you want to get involved, we have some pretty easy ways to do it right now. So first of all, just use the projects. We would love some feedback on the design decisions, features you would want to see, things like that. Really any opinion you might have while using the project, we would love to hear it. Love to see what your solutions to some problems might be. You can, of course, help with the code architecture, making sure these run efficiently, and make sure everything kind of works the way that it should and in the best way possible.
Comp could definitely get some feedback on website design. So a few months ago, I didn't really know the difference between HTML and CSS and JavaScript and why it all even mattered. And so I've learned a lot in the last few months, but I am still very much a novice. And so if people have feedback on that, I'd love to hear it. There are a lot of other cool projects I've learned about over the last few days that I think are very complementary to Comp, like My Binder, and it's you basically give it a link to a GitHub repository, and then all of a sudden it builds some running Docker containers you can interact with in a Jupyter notebook, and I think that's a really cool functionality, and I think that there are ways that Comp could use some of that repo to Docker project. And so if people have knowledge of that project, I'd love to hear their thoughts on that. And so if you want to get in touch with us, you can find us on GitHub, and you can email us. You can find Anderson on Twitter, open issue in the repos, or a pull request, or whatever it is. So thanks.
So thanks for coming, and we'll be happy to take any questions if y'all have them.